Hey, IB Physics. We had talked in class on Monday about the uncertainty in our masses of our pennies. So again, you're going to be using pennies as masses that you will use in different experiments to like change the mass of something. Um, if we were at school, we would use little masses that have labeled like 100 grams, 200 grams, and so on, but we don't have that. Um, and so I have pennies for you, which are a good way to have a easy way to change the mass of something. So that's why we have pennies. So if you haven't already, take a moment and read through the post in week 4.2, and try to contribute your own thinking to what the measurement uncertainty should be for the mass of a penny, or even just what is the mass of a penny. So pause right now and do that if you haven't already. And then from your results, we have a lot of people who did a little like Googling of penny mass or suggested that we could use a scale to measure the mass of a penny. And in fact, I have a kitchen scale. It's not like a super fancy science scale. It's actually even less fancy than this. It only goes out to the ones place value of grams. So I measured the mass of one penny and it said it was 3 grams. And then I measured the mass of a different penny and it said it was 2 grams. What? That seems really problematic because, like, shouldn't they all be the same mass? You'd think that, right? But here's the difficult thing. Pennies have actually changed composition. So you have a little table here from Wikipedia of the many different compositions of pennies from way back when. But pennies that we have for our class are either pennies that were made before 1982 or after 1982. And the before 1982 pennies were made of brass, and that's copper and zinc combined. And now the pennies that are produced are made of zinc because it's cheaper, which is kind of interesting. And then there's just a copper plating, making it that penny color on the outside, which is kind of interesting. So the funny thing, this is not related to our lab at all, but pennies made before 1982 are actually worth more than 1 penny right now. The amount of copper that's in them is worth more than 1 penny, which is kind of funny. And so that's why they changed the composition of the penny to be made of zinc instead. Um, but what this means is that the before 1982 pennies are 3.11 grams, and the 1982 to now pennies are 2.5 grams. So there is a difference here in our penny masses depending on which pennies you're using. Now, we could take a lot of time, each of you, and separate out your pennies and be like, here are my 1982 pennies, here are my old pennies, and you could separate them out and then you would know their masses, and we could have a smaller measurement uncertainty. But that's doing the most, and I don't want to have to do that, and you don't want to have to do that. So what we're going to do is we're going to say that there's an average mass of a penny is 2.7 grams. You might go, wait a second, why not 2.8 grams, Ms. Getz? That would be actually, if I average these two numbers, I would get 2.8 grams. Um, and the reason that I'm not doing 2.8 grams is because I happen to know that your penny collection actually has more of these newer pennies than the older pennies. And I did that by taking random masses and just saying, okay, well, if there's 100 pennies here, what does that tell me? So anyway, we're going to go with an average mass of 1 penny, 2.7 grams. So that's what you'll do for your lab. That's why on the lab data table, which I have here, I say multiply the average mass of the penny by 2.7 grams to go from how many pennies you have to the mass. We're going to multiply by 2.7 grams. So that's great. But we need to have some measurement uncertainty in that. So you might start by saying, okay, well, maybe the measurement uncertainty should be plus or minus 0.5 grams. That would include both of these values, right? So that's reasonable. So for the mass of 1 penny, if you're using 1 penny, that's a reasonable measurement uncertainty. However, you're not just going to add 1 penny at a time. You're going to be using multiple pennies. And so if we have a lot of pennies, if we have 100 pennies, the maximum mass that those 100 pennies could be would be 311 grams. And if you had the minimum mass of 100 pennies, those would all be the post 1982, the new pennies, which weigh 2.5 grams each. So that'd be 250 grams. So that means that I have a difference here of about 60 grams. from the maximum mass of my pennies to the minimum mass of my pennies. So what I am going to suggest we do is that we're going to use a measurement uncertainty of plus or minus 30 grams. And that's because the pennies' masses vary depending on the year they were made. We have pennies from many different years, but our total group of pennies will have masses of both pennies, both types of pennies. Oh, now you can't see that. How annoying. Which has a range of masses from 250 grams to 310 grams. So this mass measurement uncertainty is quite large, like legit quite large. It means that for your smaller numbers of pennies in your lab, when you have just like 10 or 20 pennies, the measurement uncertainty might actually be like larger than the mass itself. And again, if we were in school, we would have a way around this where everything could have its own error bar and we'd have a smaller measurement uncertainty. Heck, we'd be using actual masses, so this whole problem would be, it wouldn't exist. But we're just going to roll with it here in distance learning. When we do future labs with penny masses, we might do some like more picky mass uncertainty analysis, or even maybe cherry pick the specific pennies that are after 1982, so that you can know that they have a consistent mass. But for this lab, we want to have all of our pennies. And again, for the lab, you can go by tens. I would recommend, if you are going by tens, going beyond 50. So you need to have at least 5 sets of data here. But I would go up to 70 or 80 or maybe even 100 if you have the time. Otherwise, you could go by 20 pennies. So I could do 20, 40, what's the number after that? 60. So it's like up to you how you're going to do that. This would be the lazy route. So if you're feeling a little bit lazy, go by 20s. So start with 20 pennies, then 40, then 60, then 80, and so on. So that is going to be our measurement uncertainty. We're going with plus or minus 30 grams, and we've explained it here. You want to try to get your data collected as soon as you can so that you can allow me to like check off your data table and be like, yeah, you've done it. Because I know that there are probably going to be some of you who have some issues with measuring the stretch here. So again, remember the stretch means that you're subtracting from where the bottom of the rubber band was originally. You're hanging your mass on it and subtracting that. So if the rubber band started at 3 centimeters, like in my first video, and it stretches like down to 3.8, you're going to subtract 3.8 from 3 and get 0.8 as the stretch. And then I would add in my next set of pennies. I would say, oh, now it is stretched down to 4.2. 4.2 minus 3 is 1.2. And I would keep going, subtracting away always from that starting length. Let me know if you have any questions. I have office hours on Wednesday and on Friday, and there's actually tutoring available on Thursday. And I'll give you a little bit of information about that in class tomorrow. Hope this helps, folks, and good luck.